Hey guys, welcome back to another video. Today we're going to talk about exponential functions. So what exactly is an exponential function? Well, we're going to come back to this question. First, I want to present a problem to you. So let's say that you enter a math contest and you win. So you get first place and you find out that the first place prize is going to be money. However, you're given a couple options on the money. So the director of this contest comes up to you and he says, "Congratulations, good job. Now, you have one more math problem to solve. And that's going to be how you get this money." So you think about, okay, I'm a little tired with all this math for today, but I can do one more problem. So he says, here are your 4 options. So once I go through these 4 options, you get 1 second to decide, and you got to tell me an answer right away. So he says, all right, option A. Option A, I'm going to give you $1,000 every single day for 1 month. For 30 days, you get $1,000 every day. He says, option B, okay, we're going to give you $1,000 on the first day, $2,000 on the second day, $3,000 on the third day, $4,000 on the fourth day, and so forth. We're going to increase by $1,000 every day for a month. And then he says, okay, option C. We're going to give you $50 squared on day 1, $51 squared on day 2, $52 squared on day 3, $53 squared on day 4, and so forth. And in option D, he says, well, this one we're going to start off a little bit lower. We're going to give you 1 cent on the first day. We're going to give you 2 cents on the second day. We're going to give you 4 cents on the third day, 8 cents on the fourth day, 16 cents on the fifth day, and so forth, where every day we're going to give you double what we gave you the day before. So, which option would you like to take? And you start thinking. So, you give him an answer right away, so which answer do you pick? If you had no time to think about it, you may choose for option B, maybe option C. Probably option A or D doesn't really seem that great. But let's actually look at the total. So let's do the math and add them all up. So in option A, which is $1,000 every day, it turns out that we get $30,000. And that's just for 30 days, so $1,000 every day. Yeah. Option B, it turns out, is going to end up being $465,000 at the end of the month. That sounds pretty good. Yeah. Option C, where we had $50 on the first day, then 51 squared, 52 squared, 53 squared, and so forth. That's actually going to net us $127,055. So it actually ends up being less than option B. So we started off at a higher dollar amount, $2,500, but it turns out that all the values are actually going to be reasonably close to that. So that didn't grow that fast. And then option D, well, how much does option D really end up being at the end of 30 days? Turns out that it ends up being $10,737,418.23. Wow! So, this is the option we should have taken. But we didn't really expect it to be that big. Even if it was going to be large, did we really expect it to be $10 million? Well, turns out that this is what we call an exponential function. And an exponential function grows incredibly fast. This is one defining characteristic of it. Now, the first option we had, that's called a constant function. And we knew that because that just stayed constant, right? It didn't change. It was $1,000 every single day. Option B, where we had 1,000 and 2,000, 3,000, 4,000, 5,000, this was called a linear function, right? Because we increased the amount by $1,000 every single day, meaning our slope was $1,000 per day. That's how much it increased by. Option C was called a quadratic. This is when we had something squared, right? Now, and in option D, again, what really ended up happening was that we doubled the amount of money every single day. This then was 2 cents, really, to the x power. Well, in this case, to the 30th power. That's how much we received by the end. This is going to be a lot of money, it turns out. So let's take a look at some graphs now. So what does an exponential graph look like? So an exponential graph is going to look like this, where we start off slow and it grows very quickly. So there's 2 things that we want to note about the graph. Number 1, it always crosses the y-axis at 1. So why is that? Well, when we cross the y-axis, we know that the x value is 0. So when we plug in 0 into any exponential function, meaning our exponent is 0, well, anything raised to the 0 power is 1. So we're always going to cross our y-axis at 1. And the other thing to note about it is this grows incredibly fast. Although it may look like a quadratic in the beginning, keep in mind that it grows much, much faster than a quadratic. Or in other words, it grows much faster than x squared or any other parabola. So what else type of exponential functions could we have? Well, another one is called an exponential decay. And an exponential decay looks like this. And notice here, we're actually start off with a large number and it gets smaller and smaller. But once it starts getting small, it never actually goes negative. And the reason for that is because of the general form of an exponential function. So what does that look like? Well, the general form is going to be f of x is equal to a to the x power. So when do we get an exponential growth? When do we get an exponential decay? Well, an exponential growth is going to occur whenever a is greater than 1. Whenever a is less than 1 and greater than 0, we're going to get an exponential decay. And again, the reason for this is because what it's saying is we're going to multiply by some fraction, let's say 1/2. 1/2 to the first power. That's going to give us 1/2. 1/2 to the second power is going to give us 1/4. 1/2 to the third power is 1/8. And we're going to get smaller and smaller fractions, but we never actually get negative, which is why we approach 0 but never cross it. For an exponential growth function, we're just going to get larger and larger numbers, meaning that, for example, 2 to the second power, 2 to the third power, 2 to the fourth power grows incredibly fast. So we already saw that 2 to the 30th power grew incredibly fast, right? That already gave us $10 million in that previous scenario. But exponential decay functions get smaller and smaller, but never cross over to the negative side. So what other property of exponential functions is that it's going to double in the same amount of time consistently. So for a given function, if I know that it's going to double in, let's say, 7 years, then it's going to double every 7 years. Or if I know that a different function is going to be cut in half every 4 years, then every 4 years, that number is going to be cut in half. So we're going to see applications in two different scenarios. In science, we see exponential decay. And in finance, we see exponential growth when we're dealing with interest formulas. To wrap this up, keep in mind that exponential functions grow incredibly fast and much faster than any other function we've seen so far. If you guys like this video, give it a thumbs up and make sure you subscribe so you get updates on new videos. See you guys next time.